All right, so welcome to Statistics. Today we're going to kind of go through some introductory thoughts to kind of get you ready for, kind of diving into this. So before we get into any real specifics, we're going to take this first lesson and kind of maybe go through some of the vocabulary, go through some of the thoughts about what is statistics and what do we mean by this field, right? So the field of statistics is really kind of the collection of data, right, for the purpose of answering a question, right? And that's really what we're after. So it's not just doing math on percentages or something like that. There's the design of a study, right? So I'm going to put that up here. It is really at the heart of this, right? The design of a study. And so what I mean by that is if, every chart or statistic that you read, right? So sometimes on the consumer side of statistics, all we see is the results, right? And so sometimes that's what we have in our mind when we think of statistics. I read, 9 out of 10 students love statistics. And so you read that in an article or you read that in a book or something like that. And so you get that in your head is, okay, that's what statistics are. And that's really the product of statistics, but not necessarily the process of statistics. So the process is really how did they come up with that number? Where did they gather the data to know? How did they interview the students? Did they did they give them a survey? How did they come up with this? Did they observe them? What was their design method, right, to be able to know accurately that 9 out of 10 students love statistics class, right? And so that's really why the design of a study is so important. Most of the statistics that you read can be skewed, and so I had a professor one time that said there are small lies, little white lies, and then there are really big lies. And he said, and then there's statistics. And so the idea is that, there's a lot of room for interpretation, there's a lot of room for manipulation in statistics. Because based on how you design your study, and then even more so how you interpret the results of your study, can lead to a lot of different conclusions. In fact, you could take two different researchers, give them the same data from the study, right, from the results of the study, and then ask them to interpret it, and you may get two totally different interpretations, even though the data that they're looking at is the same, right? And then to further compound it, most research, if you really picked it apart, probably has some flaws in the way that it was designed, right? I mean, when they say 9 out of 10 students love statistics class, what were the questions on there? Was it just two? I love statistics class, or I hate statistics class. Because then in that case, maybe some people say, well, I don't want to say I hate it. So the only other option is I love it. But maybe it was neither. Maybe it was something in the middle that, I'm okay with statistics class. I don't necessarily hate it, don't necessarily love it. And so maybe by designing it with just those two options, it skewed it to where you say, wow, 9 out of 10 students love statistics. I never would have guessed, right? And so, but really all that means is maybe 9 out of 10 didn't want to hurt the professor's feelings by saying, I hate statistics class, and so they chose on the survey to put the other option. The only other option was I love it, right? And so because of the way that was designed, it maybe gave a little misleading information. And that's a very common thing with statistics. And so that's why often if you're reading journals and things, particularly if it's a formal type of research and you're going through and you're reading some kind of article from a journal, right, where they're actually talking about what they've discovered, you'll see a few different components. You'll see like the abstract. That's just the quick paragraph in the beginning that kind of tells a quick synopsis, so you can tell whether it's anything you're interested in or not. And then it will go into often just an introduction that kind of basically tells what they're trying to answer, what question they're trying to answer, the basics maybe of what they're going to look at. And then it will go into like a research, like a current, literature review, if you will, where they're kind of discussing the current thoughts that are out there about a subject. And then it goes into the main part of the article, which is the design of the study, right? And so they will spend a lot more time talking about that than other things, because other researchers are going to want to know how you set this thing up, because that will tell them how accurate your results are. If you've got a weak design, then maybe they don't want to put a lot of stock in the results that you found, right? And so when you're reading a journal article about any type of formal research, the majority of the paper is going to be taken up with, how did you set up your design and how did you execute the design, right? So, the design could be, a lot of times in medical research, they're doing, like a double-blind test or something like that, or something where someone is given a placebo. You've heard of that probably quite a bit. One group is given a placebo. They're more of a control group. And then the other group is given whatever the medicine is, and then they can compare the two. And so by setting that up, that research design, someone can come in and look at how they did that and determine whether they think their results from that survey are going to be, and from that research, are going to be worthwhile, right? So say if somebody did something and they gave one group a certain type of medicine, they gave a second group a different type of medicine, but they didn't give anyone a placebo. Then you go in and that probably wouldn't have anymore, because everybody knows you got to have a control group now. But that's why you have control groups, is because people know that. Somebody would come in and look at that study and say, well, who knows if your medicine did any of that, because there's nobody that didn't take any medicine for you to know just what a normal person would have experienced, right? And so you have to have a control group if you're doing studies on people and things like that, particularly in medical research type stuff. And so that's just an example of how a fellow researcher who is familiar with it, if they were to see that you did something without a control group, they would automatically say, well, your research is invalid, right? And so that's just an example, but there are other really important things, particularly if it's something like a survey. What researchers will be looking at is how you worded your questions, right? Did you word your questions in such a way that you can get an accurate kind of response? And so often there are more than one correct type of designs. So it's not like they're looking to see, did you get it right, in terms of the one way it could be done. They're looking at what your approach was and trying to evaluate if the approach that you're using is going to be able to produce good results. All right, so that's kind of the heart of statistics, is that what we read may just be a simple line, 9 out of 10 students, right? But the research that went into it could be fairly complex, right? It could have been required getting a whole bunch of students together. Somebody had to type up the survey. Somebody had to hand out the survey. Somebody had to go back in and review the results of the survey and put it all together, and then do the math to see how many students chose this answer versus how many students chose that answer. And the math on that was very simple. But sometimes the math on these things could be more complex, right? Depending on the type of survey that you're trying to do. And the number of questions, the number of answers, that type of stuff, right? And then there are other things that we probably won't get into too much in this class, but there are a lot of statistical programs out there that say once you've set up your design, right? If you were going to do statistics formally, you would want to become very familiar with one of these statistics programs. If you were going to do one of these, designs of a study, you wanted to research something, which would normally have to start with a question, right? You have to start with a question. You're trying to answer something, right? And so the statistics that you give out are the answer to some kind of question. How many students love statistics class, right? That's the question. And so, or maybe you started with a different type of question, but it's the same type of thing. Maybe you started with, do any students love statistics class, right? Or do any students not love statistics class? Whatever it is, you're creating some kind of question that your design of the study is trying to answer, right? And then in order to answer the question, now that one's very simple, yes or no, just one question, right? But there might be more complex types of surveys and things that people are doing to get at a more complex kind of answer. And so if you're doing statistics for a living, there are programs. Some of them are pretty expensive. The one I used for my doctoral stuff is called SPSS, and it's made by IBM. And if you were to just purchase it, I think it's like $2,000. But they will let you for like, $60 or something. You can rent it for 6 months or something like that for however long you're doing your research. And so you can go online to IBM and purchase it, and then they give you a code that's good to log in for 6 months, and you can use it. And that type of software, what they will do with that is you can have all of your data. So when you're collecting this data, and this is just kind of an overview, I'm not really trying to give too much detail, I just want us to be all on the same page, that when you're collecting data, you put it in like a spreadsheet of some kind, right? Excel, something like that. And you can then either import that data into the software, or you can just manually input it if you want. And then it gives you all kinds of options. Once that data is in the statistics software, then it can take all of the responses from all these surveys and do all kinds of things with it. If you want to find out what is the average response, the median, the mean, all those types of things, it can tell you. It can put all of it into charts and graphs. It can tell you if it's statistically significant or not, right? Say if I said that 5 out of 10 students like the class, well, then that means 5 out of 10 students don't like the class. So, maybe we didn't learn much there. And, sometimes on more complicated things where you've got several variables, it can tell you, there's different mathematical formulas, and it will tell you a certain value for whether it's relevant or not. And if it's above a certain number, then in statistical circles that's considered a relevant thing. If the number is below a certain level, then they say, well, what you found is not relevant because it's not it's not important enough in terms of how many responses were in that direction, right? And so it's kind of complicated, the math part of it, and so that's why you have to have a computer program that does it. But it takes this complicated formula and then looks at it and says, okay, that's statistically speaking, that's a significant response. And so if you were doing research for a medical thing, and say you wanted to find out how many people suffered a heart attack because of your medicine, right? So say if you have 10 million people and one person had one, well, that might not be statistically significant because maybe that many people would have had a heart attack anyways, right? So there's different ways to look at that question, but they can look at, and it will evaluate for you through the software whether it's statistically significant. Now, that's kind of getting into an area that we won't get to in this class. That's something like if somebody was wanting to be a statistics professional, that they would go in and understand that. But that's just kind of the language that they use. I want you to kind of just at least hear that a little bit, where they're evaluating the results of something, and it's T-score and other things like that is what they call it, determines whether something is statistically significant and different applications for that. Okay, so none of that's going to be on your final, that statistically significant part. That's just an example of some things that could be done with the software. Some of the other more important things might be the charts and graphs. It can plot all of those different things for you. So say if you've got, with our smaller scale stuff that we might do, we might only have 10 things on our database. But say if you're a company like Gallup or IBM and you've interviewed 20,000 people about a particular product, right? And so you've got 20,000 people with maybe 15 or 20 questions on the survey. Now you're talking about hundreds of thousands of responses, right? And so you need a program that can very quickly chart that kind of stuff, because that's beyond the scope of what a person would want to do. And so that's something, if somebody was going into professional statistics, that they would do. They would take then the design of the study, they'd take all that data, plug it into the software. And so if you're reading a journal article, often you will see certain charts and certain numbers, and all of that is produced by the statistics software. Okay. So for this lesson, though, what I really want to get into is laying the groundwork for some of the basic concepts, right? And so right off the bat, the first thing, the most important thing that I wanted you to get is that statistics really is a study, a research of some kind that has to be designed. It normally starts with a question, right? You want to know something, and then you figure out how I'm going to figure it out. That's the design of the study. Then the next part is you're going to collect in the data, right? And that could come through a whole bunch of different ways. Maybe you observe people. If you give them medicine, you observe them. Maybe you give them a survey, ask them what they think about something. Maybe you give them a test and see how quickly they do it, right? So if you were testing for brain, you got some new brain supplement that's supposed to help people think more clearly. Maybe you give them a skills test, right, before they take your supplement, and then they take your supplement, and then you give them a skills test maybe 2 weeks later after having taken your supplement every day, and you compare the times that they had in the before and after, right? And so your question was, does my brain supplement make people think faster or more clearly, right? My design is that I'm going to give them a skills test before and a skills test after, right? My data collection is going to be the results from test 1 and the results from test 2, right? And then I'm going to examine the numbers, and I want to examine the numbers between all of this, the students, because I wanted to give this to probably more than just 1 or 2 people. I want to have a good sample size, right? That's what they call that. The number of people that you're pulling this information from is your sample size, right? And so that's kind of the basics of how you would do that. And then you kind of then run the math on those 2 tests, and you would say 75% of the people who took our supplement did better on the post-test than they did on the first test, right? Or you could say, you could look at how fast they did it. So maybe they did the first test first time in an average of 2.5 minutes. Maybe the second test was done in an average of 1 minute and 50 seconds, right? And so you would say people completed it 25% faster than they did before they took our supplement. So you would say, it improved brain function by, 25% in skills tests or something like that, would be how you would then interpret that information. So other researchers, though, that's a very simple test, and it sounds like it could work. One thing that a researcher who is trying to be maybe critical or trying to analyze that study might come in and say is, well, how do you know that the difference between their improvement from taking it the first time and then 2 weeks later taking it the second time, how do you know that was because of your supplement, right? So you may need to have some people who take it before and then don't take your supplement, and then they take it a second time, and see if they also improve. Because it could be that people are improving because they've already taken it once, and they have a little experience. And maybe so now that they're taking it the second time, they can do it a little faster because they've already seen it once, right? And so it may not have had anything to do with your supplement. It could have just been the fact that they've had some experience now with the test, and they can do it faster, right? And so that's why it's always good to have some form of a control group. Okay. The three basic ways in statistics that they would explain this would be using these words. Design, right? So we've talked about that. Description. And so that is explaining the data, right? Not necessarily telling what you think about it, but almost displaying it, like your chart, your graph, whatever, so somebody can look and see what the numbers say. That's the description. So you have the design. The description is almost like a discussion of the results. So not necessarily yet at this point saying what we think the results are telling us, but it's just looking at just the raw numbers themselves. What was the results? Is there a difference in time from the first time they took it to the second time? That's the description. They finished it 25% faster. The third part is the inference. To infer, to make an analysis, a judgment, right? So the third step is inference. So then you would say, okay, if they took it the second time and they're doing it 25% faster, then my inference is that they are doing this faster because of the brain supplement, right? So you got three different things. The design, the description is going through the actual results, and then the inference is then talking about what you think you've learned by analyzing the data, right? Okay. Couple other things to think about is this word probability, right? Probability. When you're thinking about probability, this now introduces the idea of the likelihood, right, of how certain an outcome is. So if, say, 60% of the people that took that second test did faster, right, but 40% of the people who took the test, maybe they did about the same or maybe even slower, right? So then now you can start thinking about, well, what is the probability that someone who takes my supplement is going to have a positive effect? And so it's a 60%, based on this test, probability that people who take the supplement have an effect. Because just because the supplement is proven to be effective does not mean it's proven to be effective for everyone, right? And so maybe there's a probability, that you won't help. So just like in all the commercials that you see on TV for some new drug or something, they will go through, 5 minutes of, while you're taking this asthma medicine, your arms may fall off, and you may enter sudden death. Some patients have been known to explode into fire when taking this asthma medicine. You know how it is. They give you something. So what is that? They're really talking about probability, that there is not a 100% probability that taking this medicine is going to help you. There is a small probability that taking this medicine may hurt you. And so that's really, they're not using the word probability in that commercial, but that's what they're dealing with, is what is the probability that this medicine is going to help you. So if I was to define probability, it is this. It's a framework for identifying how likely a certain outcome is. Right? Probability is a framework for identifying how likely a certain outcome is. Right? Okay. Couple other things for statistics. The entity that is being studied, right? So whatever it is that you're studying, that's called the subject, right? Simple enough, right? The subject is what you're studying. right? So we're going to go through a few of the vocabulary words. Subjects are not necessarily people, right? Could be an organization. Maybe the survey is analyzing how well an organization is. Maybe it's analyzing a medicine. Maybe it's analyzing a product, right? How well does a software work? How well does this new computer function, right? So the subject is whatever it is that you're studying, right? Another word to keep in mind is population. So population, if the subject is what is being studied, right, the population is the set of all the subjects in that particular area of interest. So if I'm studying college professors, the subject is college professors, the population is all of the college professors that there are, right? So the reason that's important is because I know I'm studying college professors, but maybe I'm not going to have the opportunity or the money or the time to study all the college professors, right? So there's a difference between my subject may be college professors, but if you're talking about the population, that is all of the potential subjects. And so you may not always be able to study all of the subjects in the population. So my subject is college professors, but in reality there are thousands and thousands of college professors. So my study may not necessarily be on the entire population of my subject, right? And so that introduces the next word, which is sample or sample size. And so the sample is the group out of the population that is being studied, right? So if my subject is college professors, the population is thousands and thousands of college professors. Maybe my sample is 100 college professors that I sent a survey to, right? So those are three words that you need to know. Subject, right? That's what is being studied. Population is all of them that there are. And sample is the specific ones that are actually being studied out of that large population, right? Okay. When actually collecting the data, the sample is normally you want to be taken randomly, right? To eliminate bias. And that's a subject that we'll get into in a different discussion. But bias would be, maybe if I'm interviewing college professors, maybe if I'm just doing ones off the top of my head because I'm a Christian college professor, maybe the first 100 college professors that come to my mind that I want to send a survey to are just like me. Because I know them maybe because they're in Christian schools too. And so because that's the 100 ones that I interviewed, maybe there's a bias there that if I had interviewed just randomly, I would have gotten some from secular schools and from tech schools and some different things. And maybe my research would be more balanced if I had done it randomly as opposed to doing it specifically. Because anytime you do it specifically, it's up to the choosing of whoever's doing the study. And so their personality, their experiences, their choice can influence the results of the study. And then one other kind of neat thing that I'll kind of close with this. It's kind of interesting that they found, and particularly this applies, well, it applies to everything, but we'll see it sometimes in polling. So like when you're talking about polling for, say, the elections, right? And we've probably all seen this on TV where they've got, 10 million people in a state, 20,000 people have responded already. They've counted 20,000 votes, and then all of a sudden they're calling the election. And you're thinking, well, wait a minute. There's still 9 million people out of the 10 million who they haven't counted their votes. How are they calling this election so quickly? And it comes down to a statistical principle that the sample size is not necessarily that important, right? So if I sample 100,000 people, right? Or let me put it this way: if I do 1,000, and we'll say and we're surveying people here in Florida, right? And in Florida, let's just round, we'll say 20 million voters, okay? And if I take the same 1,000, so that needs to be the same, right? So that part is important. Like if I took only 50 from the next state and I took 1,000 from Florida, that would be different. But say we take 1,000 from Rhode Island. And I don't know how many people they have there, but I'm just going to, just for simplicity's sake, say what if they had only 1 million voters there, right? So there's a big difference between these 20 million people and the 1 million here. And so what they've found in research is that as long as these two sample sizes are the same, that this number could be really big or really small, and it doesn't matter. The accuracy is going to be the same. So if you polled 1,000 people in America and you polled 1,000 people in China, even though there's 1 billion people in China, there's only 300 or 400 million in America, the accuracy of those two studies is going to be about the same. So as long as the sample size is the same, then the size of this doesn't really matter. That's why sometimes, you know, once you start getting around 20, 30, 40,000 exit polls and they're starting to count some of these things, that's why they can be pretty accurate in what they're doing, no matter how many more votes are still left. You could have 1,000, and the accuracy of what you're doing when you're taking this 1,000 to evaluate the million is the same accuracy if you poll 1,000 out of 20 million, right? Now, if you only had 2 or 3 and these were the same, it's not so good. But once you start getting up into the thousands, statistically, they find that there is not a major difference between taking 1,000 poll out of 20 million versus 1,000 poll out of 1 million, that this 1,000 tends to represent the population about as good as the other 1,000 does, right? And so that's why they can take some of the, as long as, the thing that they have to watch for in political polling is that, you know, they have to make sure that it's a randomly selected group, because there are certain regions within a state that may be all Republican or Democrat. And so if you were to take 1,000 from a place that only votes Democrat, then that may not, you know, give you the exact, you know, percentages that you're going to want that are going to be accurate. But the principle that at least allows that to work is that once you start getting into a sample size of about like this, it accurately predicts the larger group pretty well, right? And it does not matter how large the population is, right? So this is the sample size. This is the population. As long as the sample size is significant enough, right? It doesn't have to be any certain percentage, but as long as it's significant enough, you start getting up around like this, 1,000 to 10,000, it will accurately predict the population, no matter how big the population is. You know, this will not be any less or more accurate than the other one, even though the population is different and the sample size is the same, right? So that's just kind of an interesting principle there, and so hopefully that will help you to see some of our definitions here. Total number of people in the state, that's the population. We're only going to look at 1,000 from each state. That's the sample size. The subject is voters, right? And how they voted. And then the design is an exit poll. They're going to ask you, you know, who, you know, what was your, you know, affiliation, that kind of stuff. And so, or, you know, sometimes once they get going, then they're not just doing exit polls. They're doing, you know, actual votes, and they're looking at that kind of stuff. So that the design is, you know, how they voted, right? The sample size is whatever number that they're saying precincts that have reported. And then the population is the total number of people. Right? So that's hopefully a practical example that will help you to retain some of these vocabulary words right off the beginning. All right? So next week we'll go into a little more detail. We're going to look at descriptive statistics, right? So that's basically how do you use statistics to describe what you're seeing in the data. So we'll get into that next week. But for now, we just want to lay the foundation that statistics is not just what you read at the end, that it's more concerned with the process of how you arrived at that number, right?